In this last section, the subject of couplings or constant speed ratio transmission devices will be discussed. Every compressor unit contains one or more couplings. The function of couplings will be defined. The types of couplings most frequently used in the industry today will be presented, and their limitations discussed. In my professional experience, the root cause of most coupling failures has not been the coupling itself, but the coupling system. In other words, the shaft mountings or coupling guard design, just to name a few. The coupling system will be discussed with emphasis on coupling installation, removal, and coupling guard design. The function of a flexible coupling is to transmit torque from the driver to the driven machine, while making allowances for minor shaft misalignment and shaft end position changes between the two machines. The design of the coupling should provide for transmission of the desired torque at the desired speed, with a minimum of forces and perturbations exerted on either the driver or driven shaft. Shaft misalignment exists when the center lines of two shafts joined by a coupling do not coincide. In the following figure, I will show you the various types of misalignment and shaft end position changes that can occur. But let's first examine a perfect alignment case. You can see here that the driver shaft and the driven shaft center lines do coincide, so this is a case of perfect alignment. There are actually three cases of misalignment: parallel misalignment, angular misalignment, and axial position change as depicted here. The following figure depicts a typical parallel misalignment between the rotating equipment and the driver. And in this figure here, you can see a typical case of an angular misalignment. Now, each coupling type has a maximum tolerance of misalignment and a maximum tolerance of axial position change that is noted on the coupling drawing. Regardless of coupling type, misalignment tolerance is stated in degrees and is usually as seen here. Axial position change tolerance varies with coupling type. Flexible type couplings, as the one seen here, have a lower axial position change tolerance compared to gear element types depicted here. We will see this in details in the next couple of videos.